Good morning, students. Welcome to the lecture series of soft computing. In soft computing, we are learning about genetic algorithm. In today's lecture, I am going to discuss about the different operators used in genetic algorithm. In my previous lectures, I have already discussed about what is genetic algorithm and how the genetic algorithm works. Once we select the individuals, then we apply a different operators in genetic algorithm to get the optimized or the approximate solution. There are various operators that we used in genetic algorithm. They are encoding operator, selection operator, recombination operator and the mutation operator. In today's lecture, I will discuss about the encoding operator and the different types of encoding operator in detail. Encoding is the process of representing the individual genes. Once we select the genes, then it is encoded in some form. And this method can be, we have a different encoding method like binary encoding, octal encoding, hexadecimal encoding, permutation encoding, value encoding and tree encoding. We can use any one of the encoding methods. Sometimes also the nature of the problem will decide which of the encoding method will be used. But the most common encoding method that is used is your binary encoding method. Here, the genes is represented in the form of a 0 and 1. Also, you can say that once a gene or a chromosome is selected, then it is encoded or represented by a string which can be of fixed or a variable length made up of 0 and 1. तो जैसे ही आपने क्रोमोसोम सिलेक्ट कर लिया, सबसे पहले उस क्रोमोसोम को इनकोड करना है किसी भी इनकोडिंग मेथड से. सबसे पहले हम लोग बाइनरी इनकोडिंग मेथड देखेंगे कि क्या होता है. लेटर ऑन वी विल लर्न कि ऑक्टल इनकोडिंग क्या है, हेक्साडेसिमल इनकोडिंग क्या है, परम्यूटेशन इनकोडिंग क्या है, ट्री इनकोडिंग क्या है एंड वैल्यू इनकोडिंग क्या है. तो जैसे ही आपने क्रोमोसोम सेलेक्ट किया है, फर्स्ट you have to apply encoding method to convert into a some form. बाइनरी इनकोडिंग में क्या है कि आपने जो क्रोमोसोम सेलेक्ट किया, लेट्स सपोज दैट आपने टू क्रोमोसोम सेलेक्ट किया है x1 एंड x2, देन इट इज फर्स्ट नीड टू बी कन्वर्टेड इनटू अ बाइनरी फॉर्म. So a binary form like the string will be made up of 0 and 1. If we have If we have to represent the first 50 number into a binary form, then we can represent in this way. If we have to make a 4-bit string length, and this is the numeric value. Then for we have 1. So sorry, always I write 1. It's 0. The from we are trying to find out the first 15 numbers, that is from 0 to 15 we will try to for 60 number. 0 to 15 we will represent the 4-bit string length. This is 2. Then we have to represent the 3. Then 4. We have 5. This is the 4-bit string length for 5. Then we have 6. Seven, let's come to 8 to 15. We will have 8, then 9, 10, 11, 12, we have 13, this is 14, and 15 is your 4 times 1 is the 15. So this is how we can represent the first 16 number, that is from 0 to 15, in the 4-bit string length, which is made up of 0 and 1. Now let's learn how to convert a given number into a binary number, and if a binary number is given, how we can get its real number. Let's see. If we have a number 9 and we have to convert it into a binary form, then we have to divide this number by 2 until we get the remainder 0. We have a 2 4 and the remainder is 1 0. So this is the how we find out the binary number. This is 1001 is your binary number for the given number 9. And if we have to convert the given binary number into a real value, then what is the method? Here we will have 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus, as I have a less space, so I am writing down below 1 into 2 to the power 3. So 2 to the power 3 will be your 8. 8 plus 0 plus 0. This will be your 1. So we will get the 9. So in this way, we can convert a given number into a binary number. If you select a chromosome and the chromosome is in the number, then first we have to convert into a binary form. And if we need to convert the binary form into a real value, then this is the method how we can convert it into a real value. So this is the first common method that we use to encode the given selected chromosomes. There are also other methods like tree encoding method, hexadecimal. In hexadecimal number, we, in order to convert the chromosome into a hexadecimal number, we divide the number by 16. In the case of a octal encoding method, we divide the number by 8 because we have a string of 8 length, which is from 0 to 7. In hexadecimal, the string length is 16, where it is consist of both number and alphabet. The number will be from 0 to 9 and the alphabet is from A to F. So from